Okay, to help Seymour remember which streets these shops are on, we need to use the three main clues that were given. Number one, that the two fast stop stores, their street numbers add up to 50. Number two, that all the stores are on prime streets. And number three, that the Circle B store is 2 streets away from one of the fast stop stores. There is a more detailed dealing with the product of the streets. However, that will be something that can come into handy later in the problem because we need to just deduce from the very beginning what are some of the possible combinations of streets based on these 3 primary facts. So the first thing I did is I created a table of the possibilities for the 2 fast stop stores, knowing that they have to add up to 50. I put all the combinations and then I thought we'd systematically eliminate those that are not prime. Well, 1 and 49, 1 is neither prime nor composite, and 49 is composite, so we'll take that out. We also need to take out 5 and 45, since 45 is divisible by 5 and several other numbers. 9 and 41 because of 9. 11 and 39 because of 39 being divisible by 3 and 13. 15 and 35. 17 and 33. 21 and 29. 23 and 27. 25 and 25. That leaves us with 3 and 47, 7 and 43, 13 and 37, and 19 and 31. So we know that Circle B is 2 streets away from one of these. So we're going to create another chart looking at all 3 of them, and now putting in Circle B and considering only the streets that would all be prime, but taking into account that Circle B has to be 2 streets away. So one possible order would be 3, 47, and this Circle B is 2 up from that, which would be 49. We're not going to count that because 49 is composite. Or 3, 47, and then 2 down from 47, which would be 45. Again, not going to count that because 45 is composite. But what if the first shop was on the 47th Street, second one was on the 3rd, and we went 2 down or 2 up from that, so down to 1. Well, 1 is neither prime nor composite, so we take that out. And then what about 47, 3, and then 5? We could go down, or we could go up to. Those are all prime, so that's one possibility. Okay, so now we're going to do the same thing considering 7 and 43. We can't go up to because we have a composite. We could go down to, though, from the 43, and that would give us a 41. All of those are prime, so that's one possibility. We could then consider going down to a 5 if we switch up that order with the streets. Or we could go ahead and go up, but that's not going to work because 9 is composite, so we'll cross that out. And so we now go to our next combination, the 13 and the 37. If we go up to, that gives us 39, which is composite. If we go down to from 37, we have 35, which is composite. But if we consider 13 and we go down 2, we get 11, and that's a possibility. But of course, if we go up, that's not a possibility because of 15. So that takes care of all of those. And now we consider our last combination of 19, 31. We go up 2, we get 33, composite. We go down 2, we get 29, which is a possibility, all primes. We consider going down now from 19, and we would get 17, which would work. We could also go up. But then again, we cannot go up 2 from 19 because that would be composite. So that's a no-go. Again, we have to consider moving up or down from each of these prime numbered streets because this Circle B is either 2 up or down from this one or that one. That's why there's 4 possibilities you have to discern from when you're looking at these. Okay, so there's still 1, 2, 3, 4, 5, 6 different possibilities. Here's that last hint. The last hint said that he could remember the last number of the product of the streets, but that proved enough for him to be able to deduce which one it is. So we need to consider what that product would be. Just that very last number. Now the last number is the first one you get, right? When you multiply your two numbers together. So last number of product. So we have 47, 3, and 5. You're going to have a 15 times a 47 when you multiply those. That last number, which is the first one you get when you multiply, that'll be a 5. The other possibility is 7, 43, and 41. You're going to have 7 times a 43. You'll get a 1 in your ones place, and then you'll be multiplying that by a 41. That's going to give you back a 1. Now, if you're not seeing exactly how I'm getting those, just do these on a calculator, and you're going to be recording that last number of the product. 43, 7, and 5. Again, 7 and 5 gives you 35 times 43. You're going to have a 3 times a 5. That first number that's going to be produced is a 5 again. We see these are repeating. So we're looking probably for a unique number to come up. 37, 13, and 11. 7 times your 3 is 21. Times the 11, you're going to get another 1 in there. A repeat. 19, 31, 29. Again, I'm just looking at the ones to get an idea of what I'm going to get for the last number of my product, which is the first one you multiply. So 9 times 1 is 9, times another 9, 81. So you're going to have a 1 in there. Another repeat there. So 31, 19, 17. 1 times 9 is 9. 9 times 7 is 63. You're going to get a 3. This is the only one that has a unique number for the last number of the product. So the 3 stores would have to be on the 31st Street, the 19th Street, the 17th Street. They are all prime. These two guys add up to 50, the 2 Fast Stop stores. And this Circle B would be 2 streets down from one of the Fast Stops. And that's the answer.